Hey everybody, this is Mr. Storm. In this video, we are going to finish up the Cranky Chickens project we've been working on for the last couple of weeks. We're going to do quite a bit in the next couple of weeks here. We're going to get a lot done. First thing I want to do, before I forget to do this, so I've been thinking about this slingshot down here, right? Our little slingshot and our little rubber bands here. And I've been thinking about implementing a script that allows those rubber bands to stretch when you pull your bird. So I started writing the script for it, and I realized it's way more than I actually wanted to do for this project. So we're just going to get rid of the rubber bands. Sometimes that happens when you're in the middle of developing a game and you're like, wow, I got this really great idea for something that I want to do. And then you go to do it and you realize it's a lot more work than it's worth. So let's get rid of it. So what I want to do is go to the prefab, not the object in the hierarchy, but I want to go to the prefab itself. And let's open it up. Inside the prefab here, I want to delete the rubber left and rubber right. Okay. Now that's going to allow us to have a slingshot that doesn't have the rubbers. Okay. Cool. Sounds good. All right. So that's the first thing we got to do. Just a little bit of cleaning house. Next thing is let's check out the functionality of our game here. So we've got our bird. We can rotate. We can launch the bird and he does some cool stuff and then kind of hits the ground and whatever. That's kind of boring. So what I want actually is I want a really cool effect. I want some feathers to poof off of the bird whenever he collides with the first object. And so I've made this particle effect here, this particle system with some feathers. So I have this particle system that will fire off whenever we do something, but we've got to write a script to handle when this particle effect will happen. So let's go ahead and write that script. So go to your scripts folder. And I'll just open up all my notes on this other screen. By the way, if you thought that I had all this stuff memorized, some of it I do. Others, sometimes I have to refer to my own notes too. That's okay. So what we're going to do is we're going to create a script called collision spawn once. It's a pretty generic name, but it describes exactly what we're doing. Basically, we are going to collide with an object and then spawn something one time. So collision spawn once. Okay. Let's go ahead and open up this script in Visual Studio and give it a minute. Okay, perfect. Okay, so for collision spawn once, this is actually going to be pretty easy. Let's get rid of our start and update methods. We don't need them. What we need first is we need a reference to the effect that we want to trigger once we collide. So let's create a public reference. So public game object. Now particle effects are just like any other game object. We can reference them by their game object. And we will name this effect. That works. Now we want to create an onCollisionEnter method. So void onCollisionEnter2D. Okay. And now we need to use that instantiate method that we talked about last week that will allow us to instantiate a prefab. Instantiate, remember, it has 3 arguments that you need to give it. The first argument is the reference to the object you want to instantiate. The second argument is its positional data. So where is it going to exist in the scene? And the third object is its rotational data. How is it going to be rotated when it comes into the scene? And so for us, it's pretty easy. Instantiate. And then the first argument is going to be effect. The second argument is going to be transform.position. And, not dot normalized. And the third object, or the third argument, is going to be quaternion.identity. Perfect. That's pretty easy. Now, we only want the feathers to puff on one collision, because if we leave it so that it puffs every single time, so this particle effect puffs every time we collide, when the bird is rolling along the floor, it's going to be puffing up a bunch of feathers and it's not going to look great. So what we want to do is we want to destroy this script after the first time this fires. So destroy this. Okay, now this script is done, actually. So let's go ahead and save all. And let's go back to Unity. Oh, I'm in play mode for some reason. Let's get out of there. So now we have our collision spawn 1 script. We need to add this to our bird prefab. So let's open up the bird prefab, go to our scripts, and add in collision spawn once. Oh, let's make sure it gets actually dropped in there. Okay, now it's asking for a reference to the effect. So go back to prefabs and drag in this feathers particle effect. Perfect. So let's test this out. Let's see if our feathers actually work. All right, so I'm going to shoot it right at the ground. Puff. Ooh, that looks so good. Oh, that looks so good. I love it. Okay, so the particle effect will fire off. Oh, that one didn't really work. It'll fire off as soon as it hits the ground or hits an object for the first time. Great. Okay, so now we have one more thing that we want to do to make our bird just a little bit more dynamic. Now this next thing we're going to do, it's both a design choice and it's a gameplay choice. You'll see what I mean, all right? So let's go to scripts and let's create a new script. We're going to call this trail. And maybe I should explain what we're going to do here with trail. Let's look at our prefabs. In the prefabs, we have these 3 white balls, essentially, these white puffs. These are the trail objects. What we want to do is whenever our bird launches across the screen, we want it to spit out some trails behind it, like fart out some little puffs of air, so that we can track the trajectory our bird took. Now, it makes it look nice, it looks good, but it also helps us as the player to gauge how to aim our next shot, right? So the first shot, maybe it went a little bit high, and we know that because we can see the trail. So then we can aim it a little bit better on the next shot. Now, we don't want the trail to be made up of just one puff because then it just looks consistent and it looks kind of weird. So we're going to create an array that rotates through these 3 and creates them in sequence behind the bird as it flies. So that's the script that we're about to write. So let's go ahead and open up trail. Okay. Now let's get rid of the comments here. And actually I don't need my update method, so let's get rid of that. Okay, we need a couple of objects, or variables, sorry. The first thing we need is an array to hold all of our trail objects. So it's going to be a public, and it's going to be a game object array. You can make an array of game objects. We're going to call this trails. And then I want an integer that will handle what is the next index that we're going to go to. So we're going to start that at 0. Because remember, this is an array. So the first array is 0, and then 1, 2, 0, 1, 2, 0, 1, 2, 0, 1, 2. All right? Okay, so inside the start, let's do this in a minute. Let's write a new method. So this method is called spawn trail. All right. And this method is really just going to spawn a trail if the bird is moving faster than a specific magnitude, right? We don't want to spawn trails while it's sitting there in the slingshot waiting to get fired off, right? So we're going to wait until it's moving fast enough. So we need an if statement for that. If get component, let's grab the rigid body 2D because we need to check its velocity dot, and we're going to do square magnitude. Now, square magnitude is something we've used a couple times so far. It's better for physics calculations to use square magnitude than it is to use magnitude because square magnitude is a lot more efficient on the programming side. It allows your computer to do the calculations for physics speed of an object in the physical, 2D and 3D space than just regular magnitude will. So we're going to use square magnitude just to make it a little bit easier on my computer, right? And we're going to say if the square magnitude is greater than, let's say 25. So if our bird's moving faster than 25, then we want to instantiate again. Now, instead of instantiating a specific prefab, we're going to instantiate an index in an array of prefabs. Complicated but fancy. You're learning some good stuff here. So the array is trails, and the index we want to grab is next. All right, and then transform. Oh, if I can learn how to spell. Transform dot position and quaternion dot identity. Perfect. So we're going to instantiate the next index of the trails array. Now we need to figure out how to move next from 0 to 1, then from 1 to 2, then from 2 back to 0. So because there are only 3 indexes in this array and we're starting at 0, we can actually use a little bit of a math trick to make this work. Normally we'd have to use like an if-else statement and move it through the whole thing. But we're going to use a trick. We're going to use a math trick. So we'll say next equals next plus 1, meaning move to the next number. So if we're at 0, we start at 1. Then we want to modulus my trails dot length. Okay, so what that is doing is it's going to, let's start with the example of 0. So it's going to start at 0. This becomes 1. 1 modulus trails length. Trails length is 2, right? Or 3, right? So 1 modulus 3 becomes 1. Yeah, because the remainder is 1. And then in this example, 2 modulus 3. So basically we're just using this trick to try to like force it. But once we get to the end of the array, we get to like, actually we get to 2. It'll come back around because actually trails.length is 2. Yeah, so that's how the math is working. Sorry, I was just trying to think through it in my brain. Once it gets to 2, it'll come back around to 0 because 2 modulus 2 is 0, right? 2 modulus 0 is, yeah, we'll never have 0. So yeah, 0 then goes to 1. 1, 2, 1 modulus 2 is 0.5. Yeah. Just know that this math trick is going to work for us. I'm trying to explain it in a way that doesn't get too deep into what modulus really does mathematically, but it's fine. Just know this will work. Okay, at this point, that is done. Let's save this. And all right, so we need to attach this trail script to the bird prefab. Let's open up our bird prefab. And let's attach our trail script. Now, we need to add the trails objects into the array. So our array is going to be a size of 3. And we're just going to drop these in. Boom, boom, and boom. All right, now let's play it and see if our trails work. It didn't. I saved. What did I do? Oh, I created this method, but I didn't invoke it. I need to actually invoke the method. My start method is empty, which means nothing is happening. That's awesome. We forgot one statement. And we forgot something that is new that you've never used before called invoke repeating. Okay, invoke repeating will basically repeatedly invoke a method. It'll fire off a method at a specific interval, which we're going to set here. Now, the method we want to fire off is spawn trail. And the next argument is the time. So let's do 0.1 float. And the next argument after that is the repeat rate. And we'll do 0.1 float. Okay, so that statement is what we were missing there. We weren't actually firing off our method. So now let's save it. Come back, let it reload there. Now let's play and see if it's working. Oh, beautiful. Look at that. And it just, oh, it's so clean and nice and clear. Boom. Oh, that's so perfect. And it's you can tell it's alternating from big to small. So it looks nice and clean. And it allows me as the player to really get an idea for where I've launched my bird. Okay, so our bird's looking great. It's behaving great. Now we need something for the bird to interact with. If you go to the prefabs folder, you'll notice I have a bunch of stuff in here. We've got we've got an ice block, a pig block, we've got a stone block, big, a stone block, small, we've got wood. So there's all kinds of stuff we can mess around with. I want to mess with the ice block first because this is going to have a bit different functionality than the other stuff. So I'm going to bring in an ice block. I'm going to zoom in on it right here. Now these objects have rigid body 2Ds and they have gravity applied. So if you put an ice block up like that expecting it to stay in place, it will not. It'll fall. Okay. If you put any of these objects, this is a physics game. It's a physics-based game. So let's see. I'm going to rotate. So I'm going to rotate my ice block 90 degrees on the Z-axis and bring it down there. I'll bring in another horizontal ice block like this, and then I'll bring in one and rotate it 90. And I'm just building a little structure here that we can interact with. Okay. So now I have something I can shoot my birds at, and notice that whenever it collides with them, some things happen. There's a big explosion and all that stuff, right? With the ice block, though, I actually want them to be destroyed if the bird is moving fast enough. Okay, I want the ice block to be destroyed. And we're going to want the same functionality for our pig as well. So we're going to write one script that handles both of those things. So let's go to the scripts folder, create a new script, and this one, let's call it destroy on collide. Sure, that's a good idea. That'll work. I mean, it really doesn't matter what we name it, right? I just wanted to describe it well. Destroy on collide. Let's see. Okay, so now what we want to do inside of this destroy on collide or break on impact or whatever kind of script you want to call it, we need a couple things. First, I want to figure out how much force is needed to actually break this object. So we're going to create a public reference for this or public variable for this so that we can change it based on the object we're using. So public float, we'll call it force needed. There we go. Force needed. And we'll set it by default to 1,000. Okay. Now we need to create a new method called collision force. Basically, this is going to be a method that returns a float value, and it's going to calculate the force of the collision. So it's going to take in some values, and it's going to figure out what the actual total force of that collision was. So let's do float, and we'll call this collision force. Now it's going to take in a collision 2D value, which we'll call, let's call it other. All right, so now inside my collision force method. Now, collision force is mad because we have a return type for this method, but we haven't returned anything yet. We'll fix that in a minute. So inside the collision force, we need a float that will store our actual speed so we can do some checking. We can check to see if that collision force is enough. So let's do float speed, and we'll say other dot relative velocity. Relative velocity is going to be, basically it's a smoother check for velocity, and we're going to do square magnitude. All right. Okay, so that's going to store effectively that's our speed, right? And then we need to check if other dot collider dot get component. We need to check if the thing that we collided with has a rigid body 2D. So yeah, if other dot collider dot get component has a rigid body 2D, open and close parentheses there. Then let's return speed times other dot collider dot get component rigid body 2D dot mass. Okay, so if it has a rigid body component, then we're going to return the speed times the mass, so we can figure out our force. Now, if not, if it doesn't, then we'll just return our speed. Okay. Then, so now we have a method that checks to see what the collision force is. So now, whenever we collide, so we need to on collision enter 2D. So when we collide, we need to call collision force and compare it to force needed. So if collision force, and we'll pass in collision, is greater than or equal to force needed. So basically, if our collision force is greater than or equal to the amount of force that we set, which is needed to destroy the block, then we will destroy game object. Okay, now for this project, that is the last line of code you will have to write. Let's go ahead and save this. And come back over here to Unity. And let's go to our prefabs and open up our ice block prefab, because we need to dump in this destroy on collide script. So now that I've applied it to the prefab, it should have applied automatically to all of the objects I've already dumped in, which is good. That's what we want. Now there's another prefab we want this to attach to. We want it to be on the pig as well. So I'm going to bring in destroy on collide. And I don't want it to be 1,000 because I want our pigs to be kind of squishy and destroy easy. So I'm going to set that to 300. Okay, so now at this point, we can build our levels. And you can just kind of go crazy with it. You know, bring in some wood, and kind of see how physics works. I'm kind of building like a weird tank thing here. But yeah, just kind of get creative. Now, we haven't written a script that will catch to see if we've killed all of the pigs in the level, but that's okay. You know, just once the pigs are all dead. Oh, my pig has fallen. Boom. Once your pigs are all dead, then you can hit the back button to go back to the level select. Now, I want you to go into each level, and I want you to build saves. So I'm just saving my game. I want you to go into each level, and I want you to build out stuff. You have this entire area to work with, and these blocks to work with. Bring out multiple pigs. You know, build a house, build a mansion, build a castle, build, you know, all kinds of cool stuff. And I want you to build all 6 levels. That was cool. I want you to build all 6 levels. So when you're done with a level, go ahead and save it. Save project. Then you can open up a new scene. Let's go to level 2. Uh-oh, we don't have a slingshot in this level. Well, luckily, because we've built everything as a prefab, luckily we can just grab our slingshot prefab, drop it into the level, let's say -22, add a +3. And when we play, everything works properly because it was tied to a prefab, okay? So all you have to do is bring in your slingshot and then start building your levels. I want you to build all 6 levels for this game, okay? You have 2 weeks to do all the stuff we did in this video and to build all your levels. So that should be plenty of time. I want you to have fun with this. Enjoy it, because this is, you know, this is a really fun project. And when you're done, you'll have an entirely complete game, a full game that you can show off to your friends. You can go up here, go to File, Build Settings. You can build your actual game, and you'll have, the game files. You can put them on a flash drive. You can show them off to your friends. You can say, hey, play this Cranky Chickens game that is completely original and no one's ever done anything like it before, and it's totally not a ripoff of a game that millions of people have played. But I built it myself, and you can, be proud of the stuff you're making, because we're doing cool stuff, right? I know there's some math involved and a little bit of physics and stuff. It's fine. We're doing cool stuff. Okay, that's it for me. Enjoy building this game, and I can't wait to see what kind of levels you guys come up with.